Okay, so in preparation for your test, we have decided as a class, we'll be taking our test and we need to review first. So I'm going to go over the same handout as your test review that you got I think I posted it last Wednesday on Canvas, and handing you a hard copy of it in class so we can go over the test review. The format is pretty much identical, okay? So in number 1, it says, in the space provided below, please draw an atom with a mass of 12, a +1 charge, and it says it has to have a stable nucleus. All of those requirements are going to be given. So the best strategy that I can think of for you guys to work this out is to first think about, okay, I'm going to have 3 particles. I'm going to have protons, neutrons, and electrons. So I want you to think about how many of each particle goes into your atom before you make your drawing. So the first thing we're going to look at is the mass. Now, does this tell us that we have to have a certain atomic number? Because that determines the protons. No, it does not. So for a mass of 12, what makes up the mass of an atom? Protons and neutrons. So your protons and neutrons make up the mass, and so we know that there's got to be a certain combination that equals 12. Well, the other little hint is that it says it has to be stable. For it to be stable, you can have an equal number of protons and neutrons, or you can make it unequal, where you can have more of what? The neutrons, because they space out the protons and keep them from touching. So that means we can go with like 6 and 6, or like 5 and 7. What do you want? So do y'all want to make it even or not? It doesn't matter. Even? Okay. So we'll just do 6 protons, 6 neutrons, and that gives us that mass. Because they're equal amounts, it is stable, okay? And then the +1 charge. Well, I want to make sure that y'all remember in your notes somewhere I had told you that if you take the atomic number, which is the number of protons, and you subtract the charge, that gives you the number of electrons. Okay? So, in this example, our atomic number is 6. We're going to subtract a charge of a +1, so we're just subtracting 1, and that's going to give us 5 electrons. So we're going to have 5 electrons in our atom. Now we can draw it. So I personally, because I know I'm going to have 12 things in the nucleus, it would be easier for me personally just to make 12 circles in the nucleus, and then color in every other one for my protons. Okay, so my protons I'm going to have colored in. Neutrons are open circles, and so I'm just going to color in every other one. Okay, now if these were uneven numbers, then I just have to concentrate a little bit more and make sure that I represent that. Now here's a little hint on your test. If you write this out, I'm only going to skim over this to make sure protons aren't touching when they're not supposed to. I'm not going to like scrutinize every little detail. So if you colored in the wrong amount or whatever, I'm not noticing that. Okay, so then for electrons, we need 5 electrons. That means we're going to need 2 rings. And how many electrons go on the first ring? So that's a really picky thing that I'm going to be making sure about. So if you have 2 electrons, you just do it like that. And then we have 3 more electrons. They're going to go on the next ring. And I'm not going to be super picky about how you arrange your electrons, but in this 3rd unit, we're going to talk about how they're arranged and why that's useful to arrange them that way. Okay? So, all right, we've got our atom. This one didn't ask us, but what is the identity of this atom with an atomic number of 6? Carbon. Okay, so it didn't ask us, but that one is carbon. Now remember, you could have had more than one correct answer. You could have done 5 protons, 7 neutrons, had a completely different answer, and it would have been correct. All right? Okay, so moving to the next one, this is a very similar question, except now it's asking us to make an atom with a charge of -2. It gives us a mass of 10. Again, we're not given an atomic number, but we can decide that on our own. and it doesn't tell us if it has to be stable or not. So let's see, we're going to have protons, neutrons, electrons. So let's decide what we're going to do. Our mass is 10, so the total of protons and neutrons has to be 10. So what, 5 and 5? Okay. I personally think if it's an even number, that's just the easiest to do. So 5 and 5. And then if we have a charge of -2, now we're going to take 5 and we're going to subtract a -2. So what is this answer? 7. So 5, right. So we're going to need 7 electrons to give it a -2 charge. So that means we're going to have 2 more electrons than what we have for protons. So if you did not copy this from the previous slide, this is literally what we're doing. We're taking the atomic number, subtracting the charge, and if the charge is negative, we're subtracting a negative number to get the number of electrons. Okay? Now we're just going to draw it because we've got the right charge, we've got the mass, we just draw this. So there's 10 things in the middle. And we're going to color in 5 of them. 2, 3, 4, 5. And then 7 electrons. So how many goes on the first ring? 2. I'm just going to make X's because they are a little easier to see. You can do it however you want. You can just do dots. It's fine. The next one's going to have 5. So 1, 2, 3, 4, and then 5. Okay. What element is this? Boron. Okay, so that's boron. Moving on, there's a question on the test that is pretty much verbatim. However, I think when I cut and pasted this or took a screenshot, I think it cut off the first part. So y'all, what is the definition of an isotope? I'm going to ask y'all that. So isotopes are variations, and you can shorten this part a little bit, variations of the same element with different what? Different masses. And you are super close about something that starts with an N that's different. So if I were to ask you specifically what particle would be different among isotopes, then it's something that starts with an N, which is neutrons. Okay, so neutrons are different, and that's letter B. This was like number 3 or something like that. It just screenshot didn't take. What's different among them are neutrons. And what is the same? What's the same particle? If they're the same element, they have the same number of protons. Okay, and I don't know if that's a question that I didn't get the screenshot of on there or if that was even asked. But just so you know, that's what's the same. Okay? So then here's another atom. I can only make a 15-minute screencast, so I'm going to do this one really fast to make sure that we get through this within the 15-minute amount of time, so I'm not cut off the screencast. So, a neutral atom with a mass of 18, that's all we need, and then we have to tell what element it is. So protons, neutrons, electrons. Mass is 18, so if we split it down the middle, that's going to be 9 and 9. For electrons, if I have a neutral atom, that means the charge is 0. So 9 minus 0 is going to also give me 9 electrons. Okay? So I'm going to draw my atom. Protons will be colored in. Neutrons are an open circle. So there's 18 of these. 1, 2, 3, 4, 5, 6. 6. Color in every other one. 7, 8, 9. Okay, and then 9 electrons. So I'm going to have 2 rings, 9 electrons. How many goes on the first ring again? 2. And then the next ring, I'm going to have 7 more. So 1, 2, 3, 4, 5, 6, 7. That's my element. Again, don't worry about the order of that second ring of electrons. I'm going to go over that in this unit. So I'm just kind of previewing the correct way to do it, but you just have to know maximum is 8 on the next ring, and then the one after that. What element is this? Atomic number 9? Fluorine. Good job. By the way, fluorine is spelled fluorine and not fluorine. Not that I'm really going to take off if you spell it wrong, but it is on your periodic table. So anyway, all right. What part of the atom determines its identity? The protons. They never ever change, so it's going to be the protons. Now on your test, these are going to be given pretty much as a table of information and not with a top and a bottom number, because that sometimes throws people off. So to figure out the protons, we look at the atomic number. I'm on number 6. So to figure out the protons, that's this little number right here on the bottom. That's your atomic number. On the periodic table, it's going to be at the top above the element symbol. Okay? So you have 6 protons for carbon. We're assuming that these are neutral atoms. That's also going to equal your number of electrons. Okay, for neutrons, we take the mass and subtract the atomic number. So 14 minus 6 is going to give us 8. Okay, any questions about that one? It's kind of doable. So letter B, we have manganese, and the protons are going to be 25. That's also equal to the same number of electrons, because the atomic number equaling the protons, if this is a neutral atom, the charges equal out and cancel, so it's going to be 25 electrons. To get the neutrons, we subtract again the mass of 61 minus 25 protons gives us what? I think it's 36, 40, no, 36 neutrons. Okay? And then same thing for letter C. I'm going to skip that because I have 3 more minutes on the screencast to finish this. Okay? So number 7, this is an exact question on your test. Word for word. Why does the periodic table give an atom's mass as a decimal and not a whole number? You can't have partial protons and partial neutrons, so how did that point something get in there? Well, it's because it's I will take off 1 point if you don't write weighted. So it is a weighted average. This came verbatim from your, what's that called? That simulation on the atomic mass. So it's a weighted average of all the isotope masses. If you can get pretty much most of that on there, you're golden. And then this last question, you have not the same thing, but something very similar on your test. You have, it gives you a little fluff about rubidium. It's telling you it's a soft metal, and it has 2 isotopes, rubidium 85, that means it has a mass of 85, and rubidium 87. So then it asks, it tells you its average atomic mass, this is really important information, is 85.47. Which isotope is more abundant and why? So what would y'all say? Which one? 85 or 87? 85. And I'll get that in a second. So 85 because, and you can just write your answer like this, and you don't have to write the whole element word out, but rubidium 85 because it's closer, I hear you, to the average. And that's it. Okay? That's what you would have to do for your test. Let me see if there's another question. And then there's one more, but that's it. All right? Okay.